Okay, let's get started. Today's lesson is on translations and reflections. I wrote both words right here because I want to keep referring to them over and over and over for this lesson. So let's get started, shall we? We shall. Okay, translations. The book just terms it, and again, I want to keep this like in really, really simple terms so it's just easy to remember. A translation is almost picturing it as like you're taking the shape. You're not changing it or doing anything with it. You're just kind of moving it across the coordinate plane, like up, down, sideways. Okay, so we could almost call it a slide, okay? Because you're kind of like taking it, if it was over here, you're sliding it up into a new area. But you're not really like spinning it or doing anything else crazy. Okay, reflections are almost as if you take this object over here, and let's say this was the y-axis here. You take it from here and you kind of do that to it, okay? We're going to call that a flip, okay? It's almost like you're taking the object, or if you had it this way, you're kind of like flipping it downward or taking it and flipping it upward, okay? So we have slides and flips, all right? My little picture here, if this was my coordinate plane, okay, a translation would be like if I had a triangle down here and I said, hey, that triangle is now over here, okay, we're going to have to like slide this guy into some new coordinates or coordinate pairs or whatever. We can use all that terminology. But a flip would be, well, let's say the triangle was like right here and I'm going to flip it downward. Then this guy would flip upside down like that and end up down here, okay? Now I know my picture isn't to scale and you might notice like, but the goal would be this distance here would be the same distance as here. So I guess I could move mine up just a little bit, kind of put it maybe like there. All right, it's a little bit better. Okay, but that would be a flip, right? Because you take it like this and you kind of flip it like that. So I'm just going to draw an arrow that kind of like brings it down, okay? So these are the two topics we're going to be working on. I want to go through some of the problems and kind of talk through them as we do them, all right? So the first one here says we got a rectangle, and let's see here, let me kind of draw this out as best I can. We have a rectangle right over here. Okay, and they're going to give you some information. Sometimes they'll give you a picture, sometimes they won't. I always say it's better to draw out the picture if you can. On a test that I would give you some graph paper or a coordinate plane because that's just going to make it really nice and easy for you to figure out, okay? And they're going to label this JKLM, so I'll label it here JKLM. And then it says here, if the table is moved, okay, I guess this is the top of a table. If the table is moved 2 units to the right and 1 unit down, find the coordinates of the vertices of the table's image, okay? So they're using the word image to say like, this is the original and this is the image that you're moving into, okay? So if it were to move, let me just write that down, 2 to the right and 1 unit down. 2 right and 1 down, okay? Then it looks like that's all they gave you. Oh, they gave you some ordered pairs. So J was -2, 5, -2, 5, and K is -2, 1, -2, 1, and L is -8, 1, -8, 1, and M is -8, 5. Okay, now this again gets back to like why you should understand the coordinate plane, why you should understand your quadrants, why you should understand ordered pairs, because now we're going to be using this stuff to kind of change things around. So let's see here, the translation or the slide of this thing is going to be a 2 and a -1. Okay, it's going to go 2 to the right. All right, we assume this guy is going that way because we were told 2 to the right. Okay, anytime if this was a number line here, if this guy is going to the right, then I know that it's sliding on the x-axis positively, right? 2 units to the right, okay? So I can put a 2 there for x. And then what's happening with it going up or down? Well, I have my y-axis here. I was told it's going 1 unit down. So all of these coordinates are going to move 1 unit down from where they were, but it's going to be the y value because the x's are going to move me side to side. The y's are going to move me up and down, right? X and y axis, positive, negative. So -1 is the other part of the formula that I'm going to need, okay? So the book does it in one way. I mean, it really is up to you how you want to do these. I think it's a good method the book uses at first because, you know, when you have negative numbers, it's just nice keeping everything in order. But here's what they do is they just list JKLM. So we have -2, 5, -2, 1, and then we have -8, 1, and -8, 5, okay? And then they write in the translation here, or what's going to happen, and then they then wrote out the final answer, okay? So, or the image, I guess we should use the right terminology. So all I'm doing is taking my x values, right? I have my x's and my y's. I have my x and my y. I decoded this by looking at it and saying, okay, they said it was to the right, which means it's +2 units on the x, and then it was down 1 unit, which means it's -1 unit on the y. So I wrote out my ordered pairs, I wrote out my formula. Now I'm just going to calculate, process, and see what I get, okay? So let's take a look here. -2 + 2, and again, this kind of gives you some space to do some work, so if you want to write them out, you can. Some people like to just do them in your head, but just take your time. -2 + 2 is 0. 5 plus -1 is -4, not -4, just 4. Okay, and then we're just going to keep on going. So at this point, if you want to pause the video, if you think you understand it, pause the video, do the rest of these and see what you get as to where the image would end up. I'm going to keep on working. -2 + 2 is another 0. 1 - 1 is a 0. -8 + 2 is -6. 1 - 1 is 0. -8 + 2 is -6. 5 - 1 is 4. And you'll start to notice that things happen in patterns, right? I end up with the same x's, the same y, some of the same y's, which is exactly what should happen, okay? So let me just double check over here. It looks like we got everything looking good. And then it says the coordinates of the vertices. And remember, a vertice is just a vertex, and a vertex is just where two lines come together. Okay, so they were calling all of these vertices. And so then what they did was, the way they wrote it was, if this is point J, then we would call this guy J, and then they put a 1 up there as a prime, okay? It's really up to you how you want to label it. If we were in class, I'd say, you know what, if you show me this and show me the new version of where it ended up, that would be okay. Some books are going to have you use like J and then J1, and this would be K1, L1, right? Because that shows that they're two different spaces, okay? Because this is J and this is J prime or J to the 1 or whatever you want to call it. It's the newer version of it, okay? Don't stress out about that. The main thing is, do you understand what we're doing here, how we're moving this guy, okay? Now, for some people, they might want to graphically do this and say, well, yeah, that's cool and all, Josh, but I would rather just redo it or redraw it and then just figure out where the new points are. So what you would do is, and I'm going to go kind of quick through this part. If my little box was over here, all of these corners here, all of these vertices would just shift 2 to the right and 1 down. So this line, this box here would go over 1, 2, and 1 down and go here. This guy would go over 1, 2, and 1 down, and then 1, 2, and 1 down, 1, 2, and 1 down. So my new box would be, I know this isn't really to scale, but my new box would kind of end up right there because I took every point. And again, when this is on graph paper, it's super clean and easy. You just start at -8, right? You go to -8, 5, make your dots, you know, draw this. Then you go over 1, 1, 2 units, right? 2 to the right, and then 1 unit down and make a new dot. And then you do that for all of these guys. And you'll end up with a box that is just shifted a little bit down and over. Okay, kind of like what I did here. Okay, for some students, that's like super easy for them. And if time is not an issue, then maybe it is better to graph it, draw the new one, and then just say, oh, well, now where are the new boxes? So where is this point here? Like, you know, it's over 0 up 4, it looks like. So you would just point, you know, say, Josh, these are all of the new points, or you could write out the ordered pairs, and that would be an answer as well. Okay, so this is more of the algebraic method. This is more of the graphic method. Okay, all right. So example 2 now has us doing a reflection. Okay, so let me get this stuff out of the way and move on with a reflection. Okay. And like I said, I left all that stuff up there because when you're first learning this, it's nice just having those vocab words, and I'm a visual person, so it's nice having the picture of what it is right next to it. So I could say, oh yeah, translation is slide, reflection is flip. If you go into a test, maybe write those down. It says here, the vertices of a figure are this, graph the figure and its image after a reflection over the y-axis, and we'll get to that part in just a minute. Okay, so you know what? I'm gonna need the book for this guy because this is kind of big. Let me do this, and the original is kind of like this. It's kind of like a diamond almost, like that. Okay, and that's pretty good. I got D, E, F, and G. Okay, and I got 4, -2, and I got 5, -5, and then I got 2, -4, and 1, -1. Okay, it says to graph the figure. Okay, I did that. And its image, okay, after a reflection over the y-axis, okay, over the, okay, that's not as important as this and this, okay, graph it over the y-axis, okay, so this is where you got to just take your time and make sure you're being careful with what you're being asked, because I have students that'll slide this thing, flip it, turn it, do like, no, dude, all I need you to do is do what the directions say, okay? We're doing a reflection, which means we're doing a flip. So it's either going to flip this way or this way. Reflection over the which axis? The y-axis, okay? The y-axis, up and down. Oh, this marker's done. The y-axis, okay? So we're going to flip this over the y-axis, okay? Now, could you just measure these points and say, well, this guy went over 1 unit, therefore this guy is going to go back 1 unit, and I can make my other dot? Yes, you can. But then, you know, make sure you just have a pattern that's going to work, okay? Some students will take that easy route and just say, well, I'm good at these points, and if I know this guy goes over that far, I can just draw the other one right here and here and here, and just kind of like fiddle with them until I make it work. Is it going to work? Yeah, it probably will. But you could also follow the mathematical method. This says to just do a reflection, okay? All right, and when it comes to these reflections, you'll notice something, okay? In this situation, okay, because all of the values are down here, all right, and all we're doing is flipping it over, you'll notice that, let's see, in this guy, the x values are going to change, okay, but the y are going to be the same, okay, and we'll say change. So the x values are going to change, but the y's are going to stay the same. And here's what I mean. The x values are going to change or be the opposite, okay, and what you'll notice is if we're reflecting over the y-axis, then the y stays the same and the x's are going to be opposites. If we're going to flip it over the x-axis, then the x's are going to stay the same, but the y's are going to change, okay? Maybe that sounds kind of weird. I don't know. That's how like the book likes to do it. It makes sense as you start to practice, okay? So if I have these ordered pairs here, let me just write them out again. I got 1, -1. I got 4, -2, 2, -4, and 5, -5. Okay. So what I mean is, in order to flip it over the y-axis, the y's stay the same. So I have -1, but the x is going to turn opposite. So if it's a +1, it's now a -1. Okay? So I'm going to go back 1, down 1, and make my point. My next point was 4, -2. The x needs to be the opposite, so I'm going to do -4. The y stays the same, -2. So I go back 1, 2, 3, 4, down 1, 2, and make my next dot. 2, -4, the x is the opposite, so I'm going to do -2. Y stays the same, -2. So I go back 1, 2, and then down 1, 2. All right, that guy is, oh, it's a 4, I'm sorry. 4 here. 1, 2, 3, 4. Looks like it's the reflection of that guy. And then I have 5, -5, okay? So the x is going to change. It's going to be the opposite, and y stays the same, -5. So I go back 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My new picture isn't exactly pretty, but on graph paper, it would certainly look a lot more smooth than that, okay? And you'll notice that what I did was I reflected it, right? I flipped it over the y-axis, okay? So like I said, if you flip it over the y-axis, like that's what you're told, the y stays the same and the x becomes the opposite. If I needed to flip this over the x-axis, then the x would stay the same and the y would change or be the opposite. Okay? All right, so now I just want to do one more problem here and make sure that we're all on the same page with some of this stuff, okay? It's just to identify the thing, whether it's a translation or reflection, and then describe what's happened. Describe the transformation, okay? So let me erase all this, because now they're just gonna give you a picture and say, hey, tell me what happened, okay? So let's see here. I have my coordinate plane. All right, let's say I got the letter C, and it's gonna move over to here, okay? Well, first tell me what happened, okay? Was it a translation or a reflection? It was a translation because it just slides, right? It starts over here, ends up over here, okay? Now, does it say to give you an answer? I don't think it does. Oh, it does. Okay, and that's fine. So what they want to know is, well, how far did this thing slide, okay? So all of the points here, like let's say these were all points like here, 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 and here that made that shape. All of them slid the same amount to the right. So I would just take the starting point here and say, well, how far did this thing go? And sometimes with letters and shapes, it isn't perfect, but I will know what you're meaning if you get it reasonably correct. So then you just count like 1, 2, 3, 4, 5, 6, 7. Sometimes it's pretty easy with the shapes. There's kind of like a definite starting point. My letters aren't as thick, but if you were to just take one of the points on this thing and pick an easy one and then just count, well, how many times did this guy move over? That would be your answer. So we had 1, 2, 3, 4, 5, 6, 7. So this is a translation. Let's see here, the proper way. What did the book say? We'll say 1, 2, 3, 4, 5, 6, 7. 7 units to the right. Okay? That would be the most technical way we could write it. Okay? It was a translation, 7 units to the right. Okay? Because it started here, it slid 7 units to the right. What if it started here and went backwards? Okay? Then it would be a translation, 7 units to the left, okay? Try not to use negative numbers. Try not to say like -7 units, okay? Try to just kind of use the format that the book is doing, okay? Let's see here. What if I had a triangle here and it ended up down here, okay? Same thing, right? Well, we know our vocab now, so we know this is a reflection, okay? And how many units here? We'll say it's 1, 2. We'll say this thing is too tall. So 1, 2, too tall. Get it? It's way too tall. And 1, 2. So I know that this guy had to move 1, 2, 3, 4 units. So it's a reflection 4 units down, okay? Because that's what it took to bring it all the way back down. That's the distance between the 2 points, okay? Just like we did the distance between the 2 points right there. All right. Okay, so those are the main things that I wanted to cover. When it comes to all of these, they just want you to find the coordinates of the vertices, okay, and then say where the new image showed up, okay? Or they wanted you to explain, based on a picture, hey, where did this guy slide or flip, and then how many units did it do that, okay? Now, if you're off by a unit these first couple times, don't sweat it, right? This is all new stuff for you, so take your time, and if you make a mistake by a unit, then just look at it and go, oh, now I see. Maybe you counted 1 extra unit. Maybe you didn't count the extra part when you flipped it, or who knows, okay? All right, quick lesson, you guys. Hopefully the vocab makes sense. We're going to be using it on and off throughout the rest of the year, but take your time with this, and I'll be seeing you.